Namaste. Last chapter of organic chemistry, amines. Directly entering to the question. Question number 1, hybrid state of nitrogen atom in amine. Easy. You know, there is a sentence in our NCERT textbook in this chapter. All amines are considered as the compounds derived from ammonia. What is the state of hybridization of nitrogen in ammonia? sp3. So same answer. Isobutylamine, second question. Isobutylamine is a primary amine. What is isobutylamine structure? Isobutyl group, all of you know. This is isobutyl. So this is isobutylamine. Agree? NH2 group, wherever it is connected, whether it is to primary carbon or to secondary carbon or to tertiary carbon. Okay, in this particular family only, primary, secondary, tertiary, that categorization is not depending on the type of carbon. NH2 group always represent primary amine, NH group represents secondary, and N represent tertiary. Question number 3, there is a correction. Correction in question as well as in option. I don't know what happened. Number of the cyclic secondary amine structures possible for the compounds with the molecular formula, you rewrite it as C4H9N. Answer is also not present in the options. 2, 3, 4, 8, that is option, but option also there is no perfect answer. Let us see what are the possible structures of secondary amine with a cyclic structure. Secondary amine with a cyclic structure. The formula C4H9N, that is a molecular formula. Secondary amine always contain a functional group NH, and I am placing CH2, 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 CH2 here. See, 1, 2, 3, 4 carbon, 2, 4, 6, 8, 9 hydrogen and 1 nitrogen. So this is one structure. The number of isomers they have asked, cyclic structures. Okay, the number of cyclic secondary amine structures possible, that means isomers. I am writing another. This is a 5-membered ring and I am creating a 4-membered ring. Okay, CH2, CH2, CH, but you have to place a methyl group here. This methyl group that is actually opposite of NH. Suppose I am placing this methyl group here or here, these two locations are exactly equivalent. So this is creating another structure and this is a new structure. So the second option from this particular structure, okay, this one. This location and this location both are equivalent. So by forming 4-membered ring, there are 2 options. Okay, nothing more. Only methyl group is left behind, and that methyl group can attach to 2 different locations. Okay, one is immediately that of my NH group and another opposite of NH group. Now I am going to create 3-membered ring. 3-membered ring means NH, CH2, okay, CH. Then CH2, CH3 will be the possibility. Suppose I am placing this ethyl group here, that is also exactly equivalent. So by using ethyl group, this is only one possibility. Now I am going to change another. Suppose I am creating methyl groups. Ethyl group can be divided into 2 methyl groups, and that 2 methyl groups can be either connected to the same carbon or connected to here and this location. So tell me what are the other options? You know, NH, CH2, C. I am placing 2 methyl group, and another option NH, CH, CH, ACS3 here, ACS3 here. So these are the possibilities. You count it and rewrite the option, that's all. So that is a correction in question number 3. Okay, I think you got the point. Clear. Number 4. Identify the reaction used for the separation of aliphatic primary amine and aromatic from aromatic dicarboxylic imine. There is a spelling mistake in the question, that's all. Directly, you know, Gabriel thalamide synthesis, that is exclusively used for the production of aliphatic primary amine. Okay, I think you know Gabriel thalamide synthesis. Okay, potassium thialamide treated with haloalkane followed by hydrolysis, you are getting primary amine. Question number 5, among the following the compound possesses maximum boiling point. See, one is butanamine, then N-ethyl ethanamine, then N-dimethyl ethanamine, and 2-methyl butane. Okay, 2-methyl butane. Anyway, one is an alkane and the remaining 3 are amine. So one thing is clear, compared to alkane, amines have higher boiling point. And among different types of amine, there is a particular order for the boiling point among isomeric amine. See, primary amine group is NH2 and the secondary amino group is NH and tertiary with a N. See, nitrogen atom is an atom capable of creating hydrogen bond. Agree? So, chance for the molecular association is more for primary amine compared to secondary, because this can form 2 hydrogen bond, this can form only 1, here no option. So, boiling point is more for the primary amine, it is nothing but butanamine. Okay, clear? Question number 6, sir. In solution, basic nature of amine follows. Solution means the basicity of a particular amine depends on 3 main factors. One is inductive effect, okay, other is solvation, hydration effect, then third is steric factor. Agree? So, normal phase is solution phase. In aqueous phase, these 3 factors are playing simultaneously. So, predictions are not possible and the basicity order should be accomplished or established only by checking the pKb or Kb value. Higher the value of Kb, more will be the basicity, lesser the value of pKb, more will be the basicity. That is a criteria. And here in the option, every amine coming from ethyl group, okay, ethyl group. For ethyl amine, primary, secondary, tertiary and ammonia is there. I will tell you an order. Okay, in NCERT there are 2 orders regarding ethyl amine and regarding methyl amine. Okay, ethyl amine, do you know? Okay, normally in gaseous phase order is tertiary greater than secondary, then primary, then ammonia. For methyl group, spt ammonia, and for ethyl group, STP ammonia, means secondary, primary, tertiary, secondary, tertiary, primary. Ammonia is the lowest. Below ammonia, aniline you can place because basicity of aniline is less than that of ammonia. Agree? So here, ethyl group, you find order. Okay. Question number 7. Which of the following compound on reaction with HNO to produce oily nitrosamine? Secondary amine produces yellow oily liquid of nitroso derivative. So find an option, secondary. Question number 8. Which of the following cannot be used for detecting aliphatic primary amine? Cannot be used. Carbolamine test, typical test for primary amine. Reaction with nitrous acid can be used because there is an evolution of N2 gas which is aliphatic primary amine. No evolution, formation of benzene diazonium chloride, that is aromatic. So reaction is the Hinsberg test is typically used for testing primary, secondary, tertiary amine, and finally coupling reaction that is normally given by aromatic. Okay, aromatic primary amine, not aliphatic. The last area, you know, coupling reaction of benzene diazonium chloride with aniline, like that. Question number 9, the reagent which converts benzamide to benzonitride. I told you the same in the previous discussion. Amide to cyanide by heating with the P2O5. Amide, benzamide, benzonitride. What is benzamide? This is benzamide, CONH2, and benzonitride means benzene ring with the cyanide group, C triple bond N. See, this is obtained by removing a molecule of water, and that is obtained by heating with the P2O5. Phosphorus pentoxide, that is the typical species used. I think the last question of the previous section. Agree. So question number 9 is over. Question number 10, which of the following reaction will not give primary amine? Amide with the bromine alkali, Hoffman's degradation, primary amine is the product. RCONH2, lithium aluminum hydride, amide when reduced with lithium aluminum hydride, you are getting primary amine. And CS3CN nickel hydrogenation, primary amine. CS3NC hydrogenation reduction producing secondary amine. So fourth one is option. Question number 11, the strongest base among the following. See, Aliphatic amines are more basic than aromatic. First one is aniline. You know, aniline is less basic. Orthotoluidine means there is a methyl group. Benzylamine is an aliphatic amine. What is benzylamine? Benzene ring with the CH2NH2 is called benzylamine. So this is typically aliphatic. And the fourth option is nitroaniline. So everything other than the third option, NH2 group is directly connected to benzene ring. When NH2 group is directly connected to benzene ring, basicity will be reduced because the lone pair on nitrogen that is participating in the resonance of benzene. That is the reason. Question number 12, the compound which is used in the manufacture of detergents. You know, that is actually in the last chapter, chemistry in everyday life, cetyl, trimethyl, ammonium chloride, ammonium bromide, etc. that is used as cationic detergent. So 4-degree quaternary ammonium salts. That is answer. Question number 13. Careful nitration of aniline in strongly acidic medium gives more meta. Even though NH2 group is an ortho-para director, in nitration reaction it is predominantly giving meta and lesser amount of ortho, comparatively higher amount for para product. And why the product is dominant with the meta even though NH2 group is ortho-para director? The reason is clearly given in NCERT. In strongly acidic medium, aniline is protonated to anilinium ion. Okay, and anilinium ion containing NH3 plus. This is anilinium ion. NH3 plus. And this anilinium ion will withdraw electron from benzene ring so that ortho and para corners become electron deficient. That means it imposes meta substitution. So identify such an option. Okay, answer is the, you find it. Question number 14, which is the correct basic strength in aqueous medium? Yeah, methyl group. I told you, methyl group. In the previous question I told you with respect to methyl group and with respect to ethyl group, and that is there with one more extra point, aniline is also there. PHANH2 means aniline. I told you the position of basicity of aniline is below that of ammonia. Aniline is, okay, again lesser than, basicity lesser than that of ammonia. Why? Because reason already mentioned, lone pair on nitrogen is participating in resonance. So it is not easily available for the protonation. That is the reason. Question number 15, A reactant carbon disulfide and HgCl2, smell of mustard oil. You know, that is a typical reaction given by primary amine. Primary amine. I will tell you the equation. Hoffman's mustard oil reaction is the name of the reaction. Okay. See, a primary amine, when I am taking RNH2 with a carbon disulfide in presence of HgCl2, let us write. Pi bond is broken up and HRNH, that when we are distributing the product is RNHC, double bond SH. Agree? And this is treated with the HgCl2. That is the second reagent used, HgCl2 high temperature. So HGS will be detached. HGS, this will be detached. And these two hydrogen atoms join with the chlorine to form HCl. So obviously this nitrogen contain a vacancy, this sulfur contain a vacancy, but this carbon contain two vacancies. So these two double bonds are shifted. So the product formed is RNCS. RNCS. That is having the smell of mustard oil. That's all. Okay. So answer is a primary amine. Identify there is only one primary amine. Question number 16. In the following sequence of the reaction, what is C, end product? Ethylamine, nitrous acid. Let us see. Ethylamine. Ethylamine, nitrous acid, HNO2. See, primary amine, it's forming unstable diarsonium chloride. Since it is unstable, easily decomposes in presence of water, N2 gas is evolved, HCl, and you are getting C2H5OH. That is the product. Okay, this is the product A. And this molecule is again treated with SOCl2. SOCl2 actually pyridine is required. Anyway, We have seen this reaction in haloalkane and haloarine. A molecule of HCl and SO2 detached. So you are getting C2H5Cl. Chloride, ethyl chloride. The best method for the production of chloro compound. And that is B. And this is treated with the KCN. KCN means KCl will be detached. So you are getting C2H5Cn, cyanide, ethyl cyanide. Propyl nitrile is the IUPAC's name. C2H5Cn. Propyl nitrile is. Okay, next one. Propyl nitrile, you have to count this carbon also. 1, 2, 3. Okay, count the carbon of cyanide group, then write the root name. Question number 17, methyl isocyanide and methyl isocyanate. Methyl isocyanide form methyl isocyanate. Cyanide, CN becomes CNO by treating with an oxidizing agent. HGO is the best reagent. Ozone you can use. Actually, you know, in Bhopal tragedy, years back, there is a drastic incident happened in Bhopal. That is a leakage of this conversion chamber, methyl isocyanide. Okay, that is turning to methyl isocyanate. That is used for the fertilizer manufacture. That is its extension. So that leakage, that conversion chamber is having some leakage. Okay, as an after effect, so many people have some difficulties. So many people died. So that tragedy is related to MIC, methyl isocyanate. So oxidizing agent can be used. Question number 18, ethyl isocyanide on hydrolysis in acid medium. Ethyl isocyanide formula C2H5NC. Hydrolysis in acid medium. Okay. See, formic acid is formed. This carbon is changed to formic acid and C2H5NH2. Ethylamine and formic acid, that is a product formed. Yeah, first option, ethylamine and formic acid. Question number 19. Let us see question number 19. See, cyanobenzene Grignard reagent P hydrolyzes to Q, then aluminum isopropoxide. See, cyanobenzene, C triple bond N. It is treated with the Grignard reagent CS3MgBr. So this nitrogen is polarized with the CN bond is polarized with the nitrogen negative and carbon positive. So automatically MgBr goes to negative and CS3 group goes to carbon. So the first intermediate formed is C. It is connected with the CS3, double bond N MgBr, and this broken down to MgBr OH is detached to get benzene ring C, CS3, double bond NH, imine. Agree? Yes, that imine immediately undergo again hydrolysis. A molecule of ammonia is detached to form a ketone. So, C double bond O CS3. So that is the product Q. This is an intermediate only, and that is P, and this is Q. And aluminum isopropoxide. From here, aluminum isopropoxide. Okay. So that CO group is reduced to CHOH. Aluminum isopropoxide, that CO group is reduced to CHOH means the product formed is benzene ring with the CHOH CS3. Identify the product from the option. It is the question number 20. Product C in the sequence of the reaction. Any confusion in this area? I am erasing it. Question number 20. Product C, aniline, bromine water, A, NaNO2HCl, B, ethanol. See, aniline, bromine water, when we are reacting, all the corners means ortho and para are substituted with bromine. So a white precipitate of 2,4,6 tribromo aniline is produced. And this is now treated with NaNO2HCl 0 to 5 degrees centigrade diazotization. NaNO2HCl, actual condition 0 to 5 degrees centigrade. NH2 group is turned to N2Cl, Br. Okay, ethanol, C2H5OH, and that is changing this N2Cl to hydrogen. So the product is benzene ring, here H, then Br. This is the product obtained. C. The name is 135, not 246, 135 tribromobenzene. Okay. So that's all about amine. Study the chapters thoroughly. In organic chapters, you prepare yourself, especially P blocker second year. Okay. Then biomolecular chemistry in everyday life, polymers, these are easy chapters. Study yourself and prepare for the examination. Okay. All the best.